Hi, from Selby, South Dakota, United States of America, August 2nd, 2017. I have already made 6 calculus videos for my class when I am in Germany in October for 2 weeks, and now I'm starting with a pre-calculus one. So pre-calculus class, this will be your first one here. My assistant, my director is Jessica Arts, coming out here. Jessica, say hi to my pre-calc class. That's Justin, there's Natalie and Macy, Cassie, Regina's over there, Miranda, and Autumn. And I think that might be about it. How's that? Do you remember those guys when you were in high school?
I can't believe they're that old already.
Yeah, you're getting old. Oh, you guys are getting old. Okay, here's what we're going to do today. And you're going to need some scratch paper for this. Okay, if you saw these two problems, 0 equals x squared minus 2x minus 8, and y equals x squared minus 2x minus 8, they're almost the exact same thing, but I wonder what the directions would be. For this first problem, your directions would most likely be solve for x. Okay, for the second problem, our directions today are going to be to graph. If I have y equals x squared minus 2x minus 8, you're going, wait a minute, didn't we do this earlier this year? And yes, you did. Okay, we did it in depth earlier this year where we had to find the vertex, the axis of symmetry, the x-intercepts and the y-intercepts and communicate your work. We're going to have an easier way of doing it to make just a rough graph. So this is going to be just a rough graph on these problems. Today we're just going to be graphing quadratic equations. Okay, we're going to get to cubic and quartic and quintic possibly on the second part of this homework assignment. All right. For this first problem, of course, we have an x squared or bigger, make your equation equal 0. This already equals 0, so we'll see if we can factor it. Lucky for us, that factors into x minus 4 times x plus 2. I love it when I have something times something equals 0. This thing has to be a 0. Oh, x would be a 4 then. Or that thing could be a 0. If that were 0, x would be a negative 2. There would be my 2 solutions. And I'm not surprised we got 2 solutions because there's an x squared. That's old stuff for you guys. Okay, now to graph. Here's what we're going to do. Jessica, you can see if I'm over here, right?
Yes. Now we can really see you.
Okay, we're making just a rough graph. Are we okay?
Yeah, we're good.
Little technical difficulties there. First step, we're going to find the x-intercepts. Okay, and just like we did before, to find an x-intercept, we're going to let y be 0. Okay, second step, and this will be new for you, I believe, and you're going to do this many, many times in pre-calculus, and then many, 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 many times in advanced place calculus. We're going to be checking the gaps. So to make a rough graph, we find x-intercepts, let the y equal 0 to find them, then we check the gaps. Here we go. Find x-intercepts. Okay, well, Jessica, grab my graphing calculator there if you would. If you had a calculator, she can just go to her y equals and punch in x squared minus 2x minus 8. Oops, x squared minus 2x minus 8. And then perhaps hit a zoom 6. Oh, there we've got our parabola. I knew that was going to be a parabola. I knew it was going to open up because that's a positive 1x squared. Okay, however, you guys are not going to have a graphing calculator when you do these. These will be on the no calculator part of the test. Okay, so first thing on this. Okay, our notes say find x-intercepts. We let the y be 0, so that guy will be 0. I'm going to do this problem exactly like we did the last problem now. I'll factor them. And we'll come up with my x-intercepts being 4 and negative 2. Okay, those are x-intercepts. All I'm going to do is make a line that looks like this. I'm going to put my negative 2 down. I'm going to put my 4 down. You don't have to put any other numbers down yet. Okay, now this is where my graph is equal to 0. 0 is round. 0 is round, so make these as round marks though, those x-intercepts, they're round. Okay, from there. Okay, now we're going to check the gaps. I need to find a number that's out on this side of -2. You can pick any number you want on that side of -2. There's lots and lots of numbers out there. But how about let's go with -3. I don't have much of an imagination. I need to pick a number in this gap. A number between -2 and 4. There's millions of numbers in between, billions of numbers in between. How about this number? I'll pick the 0. I need to find a number out in this gap. On the other side of the 4, 5 might be a real nice number to use. Let's go with a 5. Okay, now to check the gaps, we're going to go like this. I'm checking the -3. I'm checking it into this thing. -3 minus, and I'm putting a -3 in for those x's. A -3 minus 4 would be a -7. I'm putting a -3 in. -3 plus 2 would be a -1. Notice I said -7 and -1, but I don't care about the 7 and the 1. All I care about is a negative. Notice now, these two are times each other, so these two are times each other. And a negative times a negative, you know that way back from 7th grade math, should give us a positive in that gap. For my next gap, I'm going to check the 0. This is how I would expect you to communicate your work to get full credit. I'm checking the 0. 0 goes in for the x. 0 minus 4 would be a -4. I'm putting 0 in. 0 plus 2 would be a +2. Those are times each other. A negative times a positive will give you a negative for that gap. I'm checking the gaps. I'm checking the -3, the 0, and now I'm going to check the 5. Okay, notice I did not put a round mark where they are. I put a round mark where the -2 and the 4 are, because that's where my graph is equal to 0. 0 is round, so make those round. Okay, now when I check the 5 finally, I'm putting 5 in for x. 5 minus 4 is a +1. 5 plus 2 is a +7. A positive times a positive will give me a positive for that gap. I'm ready to make a rough graph. For my rough graph, okay, I have to hit these intercepts. I have to be positive on this side of the -2. I have to be positive on that side of the 4, and we have to be negative in between. So my graph is going to look something like this. And I'm done. This is a rough graph, just a rough graph. Look at Jessica's graph she put up there in the graphing calculator. Does this look somewhat like that? Jessica, hit trace on the top. -2 and enter. Oh look, yep, where x is -2, that's my intercept, exactly where they are there. Hit 4 and enter. And yep, that's my other x-intercept. This is an exact graph, this is my rough graph, and this is going to be good enough. Again, this is what your work should look, is exactly like this. Okay, next one. Thank you, Jessica.
You're welcome. The glory days.
Is it coming back to you now, we're
Yes.
checking the gaps? And you're going to do that a lot in the next 2 years if you go all the way through advanced placement calculus. Next problem. Some students look at this one and they go, what in the world? But don't let this thing throw you. Okay, we want to make a rough graph. Okay, we're going to find the x-intercepts. We always let the y equal 0, so this y is going to become a 0. Okay, this time I've got a common factor. There's an x in both parts, so I'm going to factor that x out. If I pull an x out, I just have an x. If I pull an x out, we just have the 4. This is still my x squared plus 4x, but now I love the way this looks because I've got something times something equals 0. This is old stuff for you. X could be 0, x could be -4. Regina, what have I found? What are those things? What did I just find? Those are my x-intercepts. I hope that's what Regina said there. Okay, that's where my equation, that's where my graph is equal to 0. 0 is round. So I'm going to make round marks there at -4, and that's 0. Okay, now we just have to follow our notes, that's all. Our notes tell us over here, now we're going to check the gaps. Something on this side of the -4, how about -5? In between -4 and 0, how about -2? You can use -1, you can use -3, you can use -0.7, you can use -3.999999 if you want, just something in that gap. Okay, something on that side of the 0, how about if I use a 1? Just like the last problem, I'll check my -5. If I put a -5 there, that guy's negative. -5 plus 4 will give me a negative number. These things are times each other. A negative times a negative is a positive. My next gap, I'm checking the -2. That's why I make these round. Don't check those guys or you get a 0. Check numbers that are in the gaps. If I put a -2 there, that will be negative. -2 plus 4 is positive. Negative times the positive is a negative for that gap. And finally, we have to check our last gap, which is a 1. If I put a 1 there, that will be a positive 1. 1 plus 4 is a positive 5. Don't care about the 5, but I care about the positive a lot. A positive times a positive will give us a positive. And just like on the last graph, you have to hit your intercepts. On this side of the -4, our curve has to be positive, so it's going to be up here. Then our curve is going to be negative, then our curve will be positive. Our parabola will look something like that. Okay, that's not a very good looking parabola, but this is a rough graph, and that's pretty rough. Next problem. And just, again, common factor on that one. On the first problem, I couldn't factor an x out. This one, your trick is a common factor. Algebra 1. Algebra 2. And now you're in pre-calculus.
Is there such thing as algebra 3?
Some schools have algebra 3. When I interviewed at Mulridge a few years ago, the year before I came here to teach, I would have been teaching algebra 3, and I asked them, what's algebra 3? I don't think I got a good answer, but supposedly there's an algebra 3. Well, I bet I can stump you with this one. Y equals -x squared. Write this down on your graph paper, or on your scratch paper, I mean. Y equals -x squared minus 3x plus 10. Okay, it's going to be a parabola again because it's an x squared. Justin, you're not afraid of a challenge. You can try to factor this, a -x times a positive x. Ben Von Wall tried it last year more than once, but I think you're doing it the hard way. Let's go to our notes. These are all we need for notes here from this rough graph. Find your x-intercepts, let the y equals 0. So that's going to be a 0, but now I'm going to do this. Because that's a -x squared, I'm going to factor a negative out of the whole thing. So -x squared, if I factor the negative out, plus 3x. Factor the negative out, that'll make that a minus 10. Okay, I've got 0 equals, don't lose that negative. This factors now into x plus 5 times x minus 2. If you don't believe me, go with quadratic formula, but you're doing too much work. And I haven't factored into this. I love it when I have something times something times something equals 0. X could be a -5. X could be a positive 2. Those are my x-intercepts. To find the x-intercept, you let the y be 0. In this problem, factor the negative out right away and bring him with. He's not going to affect those two answers there, however. Now to check the gaps, I need my -5. I need my 2. Autumn, you've been listening. Autumn, why did I make those round? Autumn, okay, it should be because that's where this parabola is equal to 0. 0 is round, so make those round for my x-intercepts. Okay, now to check my gaps, the number out here might be -6. The number in between these two could be a 0. The number out there could be a 3. And I say could be because you can use any number you want that's in those gaps. And here we go. Here's how this one's a little bit different. You have to bring this negative with. So that negative I'm copying down right away. Then -6 plus 5 will give me a negative number. I'm putting the -6 in. -6 minus 2 will give me a negative number. Negative times a negative times a negative will give me a negative. Jess, how you doing? Okay.
I'm trying to do this problem.
Okay. Jess is making me nervous back there, but she says she's trying to do the problem. I wish you were as eager as she was. Is. Okay, my next gap, I'm going to try the 0. That's my number that's in the gap. Again, bring this negative down. 0 plus 5 is positive, 0 minus 2 is negative. And now if I multiply a negative times a positive times a negative, that should give me a positive for that gap. Okay, my last number I'm going to check is the 3. That's what I'm going to put in for x. You must bring this negative down. 3 plus 5 is a positive number. 3 minus 2 is a positive number. A negative times a positive will give us a negative number. Okay, now look at, and we call these sign charts when we get to calculus class. Look what happens here. I have to be negative until I get to the negative 5. Then we must be, I say we, our curve is what I'm talking about. Our curve must be positive between the negative 5 and the 2. Then my curve must be negative after when x is bigger than a 2. So to finish my graph, I'm a good aim, got to hit those intercepts. Okay, and here my curve is negative, there my curve is positive, there my curve is negative, and that's a graph for us. Okay, next one. Important thing on this one, the only way it's different is that negative. You got to factor that negative out, then that negative, you got to bring them along when you check your gaps. That's the important thing on that problem. Okay, our next problem. Y equals x squared minus 3x minus 6. Oh. Macy, why do I say uh-oh when I look at that one? What do you mean you don't know? Okay, our notes tell us, find the x-intercept and let the y be 0, so I called that guy a 0 right away. And now we'll try to factor this. Uh-oh, it's not going to factor, is it? We've got to go to quadratic formula, that good old quadratic formula.
X equals negative v plus or minus the square root of a squared all over minus all over 2a.
Okay, so quadratic formula, my x is going to equal the negative of b. So negative of negative 3 would be a positive 3.
Of b squared minus 4.
And then plus or minus square root of b squared, which would be a 9. And then always minus 4. My a number is 1. My c number is negative 6. Divided by 2 times my a number. Okay, and these should be my x-intercepts. I can make them look a little bit better here yet. Okay, and that's going to be 9 plus 24 would be a 33, square root of 33 over 2. Jessica, what's the square root of 25?
A number I don't like.
No, the square root of 25.
Oh, 5.
What's the square root of 36?
6.
6. She thought I was asking her a trick question. Okay, so if the square root of 25 is 5 and the square root of 36 is 6, shouldn't this be somewhere between a 5 and a 6? Somewhere between a 5 and a 6? Well, let me do this for, how do I want to do this now? Let me get this down here. Going to have 3 minus that square root of 33 over 2 will be one of my intercepts. Okay, my other intercept will be 3 plus the square root of 33 over 2. Okay, there's my 2 intercepts. Okay, and this one should be on the left, because 3 minus that thing has got to be less than 3 plus that thing. Okay, she said this is somewhere between a 5 and a 6. Let's call them a 5, just for kicks. So 3 minus 5 would be a negative 2. Negative 2 over 2 is a negative number. In this one, that would be about a 3 plus 5 is 8 over 2. That would be about a 4. So if I were you, this is what I would check. Let me extend my line here a little bit more. If this one's a negative number and that one's a positive number, I'm going to check 0 in between them. Okay, and I always kind of don't know exactly what that is, so I'm going to go way back to negative 10. If that's about a 5, 3 minus 5 is -2, -2 over 2 is about a -1. I'm going clear back to -10 just to be safe. And on the other side also, if that's about a 5, 3 plus 5 is about an 8. About an 8 divided by 2 would be about a 4. I'm going to go way over to positive 10. So I go back 10 and forward 10, then I know I'm at least in that gap. Here we go. Okay, this one checks differently from the other ones. If I put the -10 in, I'm going to get 100. -3 times -10 would be plus 30 and minus 6. That'll be a positive number. So this gap, we will be positive. Our curve will be positive. If I put the 0 in, that's an easy one to check. If I put 0 in, that's gone, I get a -6 there. We are negative in that gap. Okay, and then if I put the 10 in, if I put that positive 10 in, I'm going to get 100. -3 times 10 would be minus 30, then minus 6. 100 minus 30 minus 6, I'll still be on the positive side. Okay, now we're ready to draw in our graph. Okay, I have to hit my intercepts. There we go. Jessica, can you go to my graphing calculator? Oh, I missed my intercept a little bit. Can you go to the graphing calculator again? Go to the y equals. Why isn't it coming on? This is brand new, should be coming on. I know I should have a smart board. Never mind. Okay, this is a rough graph. Okay, and my other one should look somewhat close to this, but it could be go much, much lower. But that's all we're making here is a rough graph. Next problem. Technology. You just can't count on technology nowadays. Justin, how do you like it in here with all those girls? Yeah, that's what I thought. Okay, where am I? Where am I? Okay, next problem, yeah. Here we go. 2 more problems to do for this lesson. Okay, to make a rough graph. Here's our notes right here. Find the x-intercept, let the y be 0. I can do that. I'll let that y be 0. Boy, I really hope I don't have to use quadratic formula this time. I'm hoping this factors. Come on, factor for me. It has to be a 2x times an x. Both my signs have to be plus. It could be a 1 times a 4. It could be a 2 times a 2. It can't be a 2 times a 2 because I can't put an even number with an even number. I've got to try the 1 and the 4. There. That should factor like that. 2x squared plus 8x plus 1x is plus 9x and plus 4. Why do I do this? Because I love it when I have something times something equals 0. If you have something times something equals 0, one of those guys has to be 0. If this were equal to 0, I'd subtract 1 and divide it by 2. If that were equal to 0, I'd subtract 4. And there we've done the first step of this. We found the x-intercepts. We found our x-intercepts. That's where my curve was equal to 0, my parabola is equal to 0, 0 is round, so I'll put round marks for these guys. Make sure you get the -4 away on the left. If you have those the other way around, then you're going to have trouble. Okay, check the gaps. How about a -5? How about a 0? How about a 3? How about that 0? How about that 0? What do you think of that 0? My director is shaking her head no. 0 is not in between -4 and -1/2. No, that's not in that gap. How about a -2 maybe? -2 is in that gap. And I could have used a 0 over there if I wanted, but I kind of like that 3. Let's go with that 3. -5. 2 times -5 plus 1 should give me a -9. Don't care about the 9, but I care not a lot about the negative. I'm putting -5 in. -5 plus 4 is -1. And all I'm doing here is checking the gaps, the second step on our rough graphs of these parabolas. Let's check the -2. And Cassie Anderson, I'm expecting your work to look like this. Communicate your work. Tomorrow we're going to get into cubic equations that we're graphing. And if you don't know how to do this, you're going to be lost on those problems. Not just Cassie, but you too, Natalie. So communicate your work the way I'm showing you up here. -2. 2 times -2 plus 1 would give me a negative number. If I put -2 in, -2 plus 4 would be a positive number. Negative times the positive is negative. See that top one, negative times the negative, that was positive for that gap. My next gap is the 3. Okay, and don't check the -4 and the -1/2. You check them, we'll get a 0. We already know those are x-intercepts. I'm checking the number that's in the gap. 2 times 3 plus 1 gives me some positive number. 3 plus 4 gives me some positive number. They're times each other. A positive times a positive is a positive. And there we're ready to finish our graph. Jessica. Look and finish that graph for us. Wow, look at her go. Watch her go. Thank you. Okay, she hit those intercepts. We have to hit those intercepts. We're positive, then negative. We're negative, we're going to be below the axis. And then we're positive again. Our parabola will look like that. One more problem today. One more. Rough graphs. Rough graphs. That's what we're doing here. We can go with this shortcut easier than what we did earlier with parabolas. On your next test, I think there'll be a problem, a parabola problem I have on there. Vertex, axis of symmetry, x-intercepts, y-intercepts, and you gotta go back to our old notes. If I don't have those things down that I want those, then you just go to these notes and you can make a rough graph. This problem looks harmless. Step number 1, right there, Miranda. Step number 1 finds x-intercepts. How do I do that, Miranda? Yep, it says right there, let y equal 0. So I'm going to let that guy be a 0. Going to factor this. Love it when I have something times something equals 0. I've got -3 and negative, whoa. That's my only intercept, is that where x is -3. I've only got one place. I've only got 2 gaps to check this time instead of 3. How about a -28? That's out in this gap. How about a 519? That's out in that gap. If I put the -28 in, -28 plus 3 is a negative number. -28 plus 3 is a negative number. If I put the 519 in, 519 plus 3 is a positive number. 519 plus 3 is a positive number. Negative times negative will be positive for that gap. Positive times a positive will be positive for that gap. And now what do? You've got to hit that point. That's my x-intercept. I've got to hit that point. I've got to be positive on both sides. So that's what I have right there as a parabola that looks like that. Mrs. Bagman, why did I try -28 and 519? Just to be obnoxious. You can try anything in the gap, and I really wouldn't try that. I probably would have tried -4 and 0, something like that. Maybe -3.1 and -2.9 or something like that. What I'm saying is you can try anything that's in the gap. What about this? X plus 3 times x plus 3, isn't that the same as x plus 3 quantity squared? So I could have written it that way. Now no matter what I put in, if I'm squaring it, it's going to become positive. If we square something, it'll become positive. So that's a little shortcut that's going to help us on tomorrow's homework with this. So quick review of this. You're going to have to do this without a calculator on your test, which you're going to take from Mrs. Begeman before I get home from Germany. I don't know if I'm at the Brandenburg Gate today or Checkpoint Charlie, or if I'm in Prague in the Czech Republic, or or Dachau, a concentration camp, or visiting a cathedral, or visiting some castles, I don't know. But when you're taking your test, and I'm over in Europe, this will be one of the problems on there, something similar to this, and you have to do it without a calculator. Part of the test will be no calculator, I'm sure. And rough graph, this is our notes. Find x-intercepts, and you've already had this here. To find an x-intercept, you let your y number be 0. Then it's algebra 1 to finish that. And then the new stuff is you have to check the gaps. Where it's 0, that's where it's round. You'll make round marks. Then the other marks where you're checking gaps, you won't. Show me what's going on. You're putting it back into this. There's a little bit of a pain in the butt when we have to use quadratic formula, but you guys are up to it. Okay? See you tomorrow.